Right, so as I said, 14.4, a couple of proper questions that are grade B rated, and they'll work towards grade A as we work through the question. You'll see this in a minute. So let's make a start then. The larger trapezium is an enlargement to the smaller one. In other words, 8 directly relates to the 12, the 10 directly to the 15, and the height of 6 directly to the 9. 6 to 9, I can see it's an enlargement of 1.5 times, 1.5 times 10 is 15, 1.5 times 8 is 12. Find the ratio of the lengths. I'm not going to do all the lengths, I'm just going to go 8 to 12, and that equals, let's have a look, divide by 4, that would be 2 to 3. That's it. And that works the same for the 10 and the 15. One more demo here if you want to. So 10 to 15, 5's going to 10 twice, 5 goes into 15 3 times. So it's a 2 to 3 ratio, therefore it's an enlargement of times 1.5. From these, find the ratio of the areas. Okay then, let's just work out the areas first, shall we? So let's just do this one. You may recall area equals half of A plus B, which is 8 plus 10. Then multiply that by the height of 6. Put an answer just there. We've got 18, halve it, 9 sixes. Let's ask the calculator. 9 times 6, of course it's 54, so that's 54 centimetre squares. And this one's going to be, just do it up here, area equals a half of, there's the A, there's the B, and there's my height. Just do that now. 12 plus 15 is going to be 27. Multiply that by 9, and then divide that by 2. That gives us 121.5 centimetres squared. So there's my large area, there's my small area. From these, find the ratio of the areas. Okay then, so the ratio of the areas is going to be 54 to 121.5. I'm not going to simplify it by doubling to get rid of the half. I'm going to leave it as it is for now. Now, rewrite this ratio in the form of 1 to n. Okay then, so let me just have a look over here. Have I done this correct? Yes. 27 times 9. Check that calculation in case. No, it's right. It's on my calculator. Not a problem. Right. Rewrite the ratio. Right, in the form of 1 to n. Okay, let's just do this. So over here then, I'm doing part 3. So I've got 54 to 121.5. If you divide both sides by 54, then the left hand side turns into 1, doesn't it? Let's see what we get. So 54 divided by 54 is going to be 1, and 121.5 divide that by 54 gives us 30. No. Then press the 5.5 divided by 54 gives us 2.25. Okay then. So I could double that, see what happens. What is the scale factor of the enlargement for the area? Well, the area enlargement is going to be 1 to 2.25. Let's just simplify that a little bit, shall we? So I've got 1 to 2.25. If I double it, I've got 2 to 4.5. And if I double again, just get rid of the half, I go 4 to 9. That's the ratio of my areas. Okay, so that's that one. I'll pause that and I'll prepare for the next question. And okay, question 4, page 295. Sorry, 205. It says these cylinders are similar. Essentially, it means that 2 relates to 10 in the same way as the 0.6 relates to the radius of 3 on the enlargement. So find the ratio of their heights. Well, I've got 2 to 10, otherwise known as 1 to 5 if we simplify. The ratio of the radii, well, that's 0.6 centimetres to 3 centimetres. Just multiply by 10. I go 6 to 30, and you can see that's clearly a ratio of 1 to 5. It makes sense because obviously the linear ratio in relation to the heights must match the linear ratio in relation to the radii. Otherwise the cylinders will not be similar, and we're told that they are. It says find the area of each cross section shading the diagrams. In other words, the area of the green circles. So we know A equals pi r squared. So here we go. Yeah, so that's going to be 3.14 times 0.6 squared. Just grab my calculator quickly. So 3.14 times 0.6 squared, that gives me 1.1304 centimeter squares. And now I'll do the same to the big one here. A equals pi r squared. Of course, it's a different radius, though it's the same old pi, apple pie. So that's 3 squared. So that's going to be 3.14 multiplied by 9 gives me 28.26 centimeter squares. Now, from these, find the ratio of their areas. Now, I know the ratio of the area is going to be 1.1304 to 28.26, but that is really difficult to simplify. So what I'm going to do now, I know the area on this side, the little one, is going to be pi times radius squared, and that's going to compare with this side, which is pi times this radius squared. Alright, so straight away I can cancel the pi's, and that gives me 0.36. So I've got it just there. 0.6 times 0.6 is 0.36, and 3 squared is 9. Now it's quite hard to see how to simplify that. If I call that 36 and 900 by multiplying by 100, I can see that 36 divides by 9 nicely to get 4, and 900 divides nicely by 9 to get 100. If I divide further, I've got a simple ratio of 1 to 25. And that is lovely and neat, but if you try and simplify this down to get 1 to 25, it's very, very difficult to see. I suppose I could divide both sides by 1.1304, but I'm sure if I divide that by 1.1304, I won't get exactly 25. That is the way pi works. It's not a rational number, and some of you know what that means from previous studies. Now, so find the ratio of the areas. I just have it's 1 to 1. It's 1 to 25. Sorry. So in terms of area, this is 25 times as big as that one in terms of the area of the top, the bottoms, and the curved surface. However you want to calculate it. Now find the ratio of the volumes of the cylinders. Well, I'm not going to go down the route of actually calculating the volume. You may recall that the volume of a cylinder is pi times radius squared times h. So I'm going to do the same technique here without having to use pi. So on the left hand side, this little one, then I go pi times radius squared times the height of 2. Alright? And that is in the ratio to this big side, which is pi times radius squared, 3 squared, multiplied by the height of 10. Simplifying down, cancelling out the pi's, that is to say divide both sides by pi. So I've got 0.36 times 2, that's 0.72, and that's 2, well 9 times 10 is 90, isn't it? We'll multiply this side by 100, I go 72 and 9,000, I believe, yes. If I divide both sides by 9, I go 8 to 1,000. And if I divide both sides by 8, I go 1 to 125. I just know that 1,000 divided by 8 is 125. Not I'm clever, I just remember that one. And there it is. Quite shocking. Look at this. Linear ratio, 1 to 5. Area ratio, 1 to 25. Volume ratio, 1 to 125. Now, if you look back at my original introductory video when I said these grade B questions will be hinting at grade A concepts, then you may look at the 5 there, the 25 there, and the 125 there, and just get those cogs working inside your head. I won't say any more, because what I'm going to do is use these ideas to do some of the grade A questions on the other page. But that, friends, is for another video. So I'll catch you later.